Hello, welcome. Our targets for today, we will be solving exponential equations by finding a common base and by taking the log of both sides. And we'll also evaluate logarithms using the change of base formula. So first, if we want to solve this equation for x, hopefully you can see that 9 would be 3 squared. So I could rewrite this as 3 squared x plus 1. Now these two have to be equal. So x minus 2 has to be equal to 2x plus 1. Now when I multiply over the parentheses, x minus 2 is equal to 2x plus 2. And now I would subtract x from both sides, leaving negative 2 is equal to x plus 2. Subtract 2 from both sides, so negative 4 is equal to x. So that is our value of our x in this equation. Now see if you can do this one. Pause the video and see how far you get. Alright, hopefully you're done. 2 to the third power is equal to x plus 6, and this is just 2 to the 5x. Since we have the same base, these exponents must be equal to each other. So now I distribute over the parentheses. So this would be 3x plus 18 is equal to 5x. Subtract 3x on both sides. So this would be 2x. And now x will just equal 9. Alright, now if I want to solve x here, now we have to think, is this 7 to some power? 7 times 7 is 49. Multiply that times 7, you get 343. Multiply that by 7, and you will get 2,104. So if 7 to the third power is 343, and 7 to the fourth power is 2,401, we know this x value has to be somewhere between 3 and 4. But it's not exactly 3 or exactly 4. So we need to think of a new method for doing this problem. Well, one thing we can do to both sides is log both sides. So I can take the log of 7 to the x power times log of 983. Now there's a rule that if we have an exponent, we can bring it out in front. So this would be x log of 7 is equal to the log of 983. So I just divide both sides by the log of 7. And I have x is equal to, well, if I use my calculator here, I can say the log of 983 divided by the log of 7. That will equal 3.541. And that is my value. And notice how we were right. It was between 3 and 4. Turned out really close to being halfway in between there. Alright, now let's look at this. 6 to the 5x is equal to 1,032. So what I would do is log both sides. Log of 6 to the 5x is equal to log of 1,032. So 5x times log of 6 is equal to log of 1,032. Divide both sides by the log of 6. So I would still have 5x is equal to, let's see what this is, log of 1,032 divided by the log of 6. I get 3.87. 3.873. And now to solve this, I need to divide by 5 on both sides to find my value for x. So my x value is going to be 0.775. Alright, so hopefully this is making sense to you. In this one, now this 3 isn't attached to this, so before we start our problem, we want to divide by 3. So I have 1.5 to the x power is equal to 17 thirds. Now I want to take the log of both sides, so log of 1.5 to the x is equal to log of 17 thirds. That x comes out front. And what we like about that x coming out in front, now we can divide by log of 1.5. So I have the log of 17 thirds divided by the log of 1.5. So log of 17 thirds divided by the log of 1.5, and my answer is 4.278. Now let's look at this problem. 1.8 times 4.7 to the 2x plus 8 equals 21. Now the first thing we want to do here is get rid of this 8. So if it's add 8, we'll subtract 8 from both sides, leaving 1.8 times 4.7 to the 2x equals 13. Now we'll want to get rid of this 1.8 by dividing it from each side. So now we're left with 4.7 to the 2x is equal to, this is going to be 7.2 repeating. So now what we want to do is take the log of both sides. So I'll take the log of this 4.7 to the 2x, and then I'll take the log of my right-hand side. Now what's great about that log is it takes this exponent and it allows us to put it out in front with multiplication. So we can say that this is 2x times the log of 4.7 is now equal to the log of 7.2 repeating. So now we're going to divide each side by 2 log of 4.7. 2 log of 4.7. Now, there's something that people do wrong as they type this into their calculator. So I want to show you how I would type this into my calculator. Because our next step just says x equals this answer. So to type it in, the top half is good, log of 7.2 repeating. So I would put a whole bunch of 2's, just so you're just not saying it's log of 7.2. Now divided by, this whole denominator has to be in the parentheses. So we'll start a parenthesis, 2 log 4.7. And since we opened 2 parentheses, I'll close 2 parentheses and then hit enter. So this answer is going to be our value for x, 0.638, say 8 if I round to 4 decimals. All right, so here's a situation. On the number of certain species of fish, N of t is measured in millions. At time t in years is modeled by the function. N of t is equal to 12 times e to the 0.012 t. What is the initial number of fish? So initially, time is equal to 0. So N of t is equal to 12 times e to the 0.012 times 0. Well, 0 times that is 0. E to the 0 is 1. 1 times 12 is 12. So 12, I should say million because it's measured in millions. The initial number of fish is 12 million. How many fish will there be after 15 years? Well, I just plug in a 15 here. So I take 15 times 0.012. I get 0.18. And then now I have 12 times e to the 0.18. Now there's a nice e button on your calculator when you hit second natural log. And if I could just type that all in at once, and so I'd get 14.3666. So that's then 0836. So that's 14 million. So 14,366,608. Now it says round to 3 decimal place. I think they're just talking right here, 14.3667 millions. But since we have the numbers, might as well write it all out. The number of certain fish are measured in millions, modeled by that equation. Algebraically find the number of years until the fish population reaches 30 million. Now we'd say 30 is equal to 12 e to the 0.012 t. So the first thing we do is divide by 12. So 30 divided by 12 is equal to 2.5 is equal to e to the 0.012 t. And now to get rid of an e, we do a natural log on both sides. So natural log of 2.5 is equal to the natural log of e to the 0.012 t. Now natural log of e to this is like saying e to which power is e to the 0.012 t, which those things cancel out. It's just 0.012 t is equal to the natural log of 2.5. So I'll just take the natural log of 2.5 and get that answer, which is 0.916, and then divide that by 0.012. So my time is 76.358. That's how many years it will take before it reaches 30 million. Now, if I wanted to find a log base 7 of 43, what I could do is say 7 to which power is equal to 43. Take the log of both sides, pull that x out in front. Now I divide by log of 7, so the log of 43 divided by the log of 7, and then we would get some number, log 43 divided by log of 7, 1.933. Now, let's look at this. How can I get from here to here? So if I had log base 8 of 40, I could go through all this process again, but I'd really just be taking log of 40 over log of 8. It doesn't take doing too many of these before you just skip out of this whole process and go straight to finding the answer. We call this the change of base property, and you can do it with any base. You just take the log of the top of the x value over the log of the a. Now, if I wanted to do something different here, since I said you could do it with any base, if you wanted to try this in your calculator, if you did the natural log of 43 over the natural log of 7, you will still get 1.933. So whatever base you want to use, you're more than welcome to use. So in this one, we take the log of 23 over the log of 4. Or in this one, we take the log of 19 over the log of 7. This one, we take the log of 21 divided by the log of 9. Now to find the correct answer, we'd say log of 21 divided by log of 9, and I get 1.386. Log of 78 over log of 4, log of 78 divided by log of 4, I get 3.143. Log of 19 over log of 2. Log of 19 divided by log of 2, 4.248. Alright, hopefully that's enough to get you through the homework for tonight.